Hello everyone and welcome to this week's video. Today I'm going to be talking about catalytic converters, more specifically three-way catalytic converters, and what three-way means is it's trying to eliminate nitrogen oxide emissions, carbon monoxide emissions, and hydrocarbon emissions, or in other words unburnt fuels. So the way it does this, inside of a catalytic converter you've got these two blocks, and one is a reduction catalyst and the other is an oxidation catalyst. And the reduction catalyst is made up of platinum and rhodium, and the oxidation catalyst is made up of platinum and palladium. So what happens is you've got, from combustion, you've got CO2, you've got carbon monoxide, you've got nitrogen oxides, you've got oxygen, water, and unburnt fuel all coming into this catalytic converter. Now the first step it goes through is this reduction catalyst, platinum and rhodium. And what happens is you're trying to eliminate the nitrogen oxides. So the nitrogen oxides will come into this catalyst, and so inside of this it's just a bunch of tiny little ducts, little micro ducts, and there's thousands of them, and that's what the air is passing through, so you're trying to maximize surface area with that design. So the nitrogen oxides will come in, and the nitrogen bond with the oxygen isn't as strong as its bond with the catalyst, so it wants to bond with the catalyst. So it'll bond with the catalyst, and when it does that, it'll weaken its bond with the two oxygens. So the two oxygens will separate off, and they may go off, or they can join together. But eventually these two oxygens are going to find another oxygen to pair up with, so that they're O2 rather than just O, which is a little more stable. So once these nitrogens are all alone here on this catalyst, they'll move along the surface. They want to meet up with another nitrogen. They prefer that bond rather than the catalyst. So once they bond with another nitrogen, their bond with the catalyst is weakened, and they split off and go off to the next step. And so then you're just left with nitrogen and oxygen, which are both perfectly harmless gases, and your catalyst, the surface, is ready to continue this function with other elements and other molecules. So then after you've gone through the first step, we've eliminated NO2 and NO, and so now we just have N2, O2, CO, CO2, H2O, and our hydrocarbons. So the next step is this oxidation catalyst, which is made of platinum and palladium. So what happens in here is the catalyst surface wants to bond with oxygens. So what will happen is the carbon monoxide and the oxygen molecules will come and they'll bond with this surface. Now once the oxygen molecules bond with this surface, they'll split up. And when they split up, the bond with the carbon monoxide is stronger than just by themselves. So they'll bond to the carbon monoxide, they'll form carbon dioxide, and then the bond with the catalyst is weakened, so this will go off and out the catalytic converter, continue on through the exhaust, and then your catalyst surface once again is free and ready to continue doing this function here to eliminate carbon monoxide. So then also within this, you're trying to get rid of these hydrocarbons. And so when we have these freed up oxygens and we've got hydrocarbons, if you haven't watched my video on air-fuel ratio, stoichiometric air-fuel ratio, that may help. Basically, your hydrocarbons and your oxygen are going to form H2O and CO2. They're going to combust within this, react within this catalytic converter, and so they'll be forming the harmless H2O and then the kind of harmful CO2. So catalytic converters do not eliminate CO2, but they do eliminate the other gases, NO2, NO, and CO. So after it's gone through this phase, then you're just left with N2, O2, CO2, and H2O. And catalytic converters can do this on about a 90% efficient basis. So there's still going to be some of these harmful gases left over, but about 90% of them it can convert, and some obviously are better than others. And catalytic converters, one thing to note is they work best once heated up. That's how the reactions occur a little more easily. So that's catalytic converters and their function. If you haven't already, I would recommend watching my video on exhaust systems. It kind of gives you the basic overview. Thanks for watching.